Good evening, students. In previous classes, we have covered lexical analyzer, the role of lexical analyzer and the phases of lexical analyzer. And in that, we learned and we have discussed how to find the tokens. How to find the tokens. Majorly asked question in GATE from lexical analyzer or in a role of lexical analyzer is how to find the tokens. From that we have did more number of problems in class, as well as I have given some problems to you to work out. I think you finished those problems. If you want solutions for those problems, I will explain again. Or else, if you tell the answers, I can see the is it a right answer or not, like that also I can say. So that is the thing we have to do. And after that, I will move to the parsing. Before going to move to the parsing, please tell me the questions what you required from the given homework. Yes, sir. If you need, I will explain all the questions are also, or else the required questions only I will explain if you respond. At least you please tell the questions explanation is required or not. Yes, sir. Have you finished those questions or not?
ఏబిసిడి అనే ఒకటి ఇస్తే అది ఇండివిజువల్ టోకెన్ కింద తీసుకుంటామా, లేకపోతే అంతా కలిపి ఒక టోకెన్ కింద కన్సిడర్ చేస్తామా సార్?
Sir, please ask once again.
సార్
మరలా ఒకసారి రిపీట్ చేయమ్మా క్వశ్చన్.
ఏబిసిడి
యా ఏబిసిడి
ప్లస్
ప్లస్
ఓపెన్ బ్రేస్
సార్
ఓపెన్ బ్రాకెట్.
I'm having the question. Okay. Open brackets plus
5 plus 6 by 2
plus 6 into
plus
6
2 minus 5 plus
yes
into by 2.
1 minute, sir. A B C D plus
2 minus
5 plus
into
6
by
by 2 minus
plus
semicolon. Yeah. Yes, sir.
We consider that ABCD as individual tokens or single tokens, sir?
ABCD means
ఒక టోకెన్ కింద కన్సిడర్ చేస్తామా, లేకపోతే ఇండివిజువల్ టోకెన్స్ కింద కన్సిడర్ చేస్తామా?
ABCD is the one token only, sir, because when lexical analysis starts the scanning, it starts at A. So after that, again another letter is there. So for identifiers, we have written like this, sir. So any letter followed by the any letters and digits. So that is recognized as a single token, identifier token. This is an identifier token. Okay. Is it clear, ma'am?
Yes, sir. Clear, sir.
Yeah. How many number of tokens are there? Suppose if it is a single token, how many number of tokens are there?
14, sir.
14 tokens are there. Is there any lexical error in this?
Yes, sir.
What is the lexical error here?
Brackets layer, sir.
Yeah, there is no closed brackets. There is no closed brackets. But that is not the lexical error, because in lexical analysis, we are not considering the structure. Here we are considering only the tokens. How many number of tokens are there? The different types of tokens are keywords, or variables, or identifiers, constants, operators, and special symbols. So this is an identifier, this is an operator, this is the special symbol, this is a constant, operator, operand or identifier, operator. Is it an XOR or operator? Is it a multiplication operator or XOR?
Multiplication only, sir.
No, sir. In computers, the multiplication operator is, or in programming languages, in any programming language, the multiplication operator is asterisk or star. Okay, so this is an identifier, sir. This is not an operator, this is an identifier. Suppose if they ask how many number of operator keyword tokens are there, like that, so you may get the chance to put the wrong answer, because this is not an operator token. This is not an operator token. This is an identifier token, because we are having symbols plus, minus, asterisk, division, modulo, cap, like this. These are the operators. Or else less than or equals to, greater than or equals to, not equals to, or else with this symbol not equals to, are the symbols which comes under operators or operator tokens. This is not an operator token, sir. This is an identifier token. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 is the correct answer only. But if they specifies how many number of operator tokens are there, how many number of constants are there, how many number of identifier tokens are there, like that, there may be a chance to confuse here. This is not an operator, sir. This is an identifier, because we don't have this symbol as an operator in our programming languages, any C or C++ or Java, Python, any language, sir, like that. Okay, sir. Is it clear, ma?
Yes, sir.
Sir, is it clear? Yeah. Yes, sir. Is there any question required other than this? I think 4 or 5 questions we have to solve the questions. Okay. What about this one? How many number of tokens are there for this? Printf total equals to %d \n comma score. How many number of tokens are there, sir, for this? What is the answer you got, or else?
14, sir.
Sir, 14?
Yes, sir.
Okay, one answer is 14, sir. Is there any other answers? Other than this answer, is there any other answers? Yes, sir, let me check. So printf is a function or a identifier or keyword? What about printf, sir? Printf is an identifier or keyword, or what is this? This is an identifier only, sir, because identifier means the name for which is given to the variable or function or array or structure or pointer, anything, sir. That is a name. So printf is also the one of the name for which is given to the predefined function. So this is one identifier. Next, this is second one, special symbol. So I already told you what is that. When the double quotation started, from that to the double quotation ended, the total one is considered as a single token. When the double quotations started to the double quotations end, between the total one is considered as a single token. So this is the third token. Second, first, 1, 2, 3, sir. After that, comma is there, that is 4, sir. And score, this is the variable name. So that's why this is considered as identifier token. So this is fifth one. And closed parenthesis is a special symbol. It is considered as sixth one. And semicolon as a special symbol, it is considered as seventh one, sir. So totally we are having 7 tokens. Totally we are having 7 tokens. So here there may be a chance to do the mistake, sir. So please keep it in mind. So when the double quotation started, from that to the double quotations end, the total one is the constant. The total one is the constant. So that's why we consider the total between the starting double quotations to the end double quotation is considered as a single token. That's why the total number of tokens in this one is 7, sir. Is it okay, sir?
Okay, sir.
Yes. Yeah. One more question, sir. So one more question is there. Float I equals to 1.25. How many number of tokens are there, sir? How many number of tokens are there? Is there any error in this? Is there any error in this?
Semicolon lines.
Semicolon is not there. Okay. So many number of times we have discussed, sir. The thing is, here we are not considering about the structure. In programming languages, we see the syntax, we see the semantics, we see the fatal errors, and we see the lexical errors all together written at the same time. But here in the lexical analyzer or lexical analysis, it returns token or else error. Suppose you need to check, is it a token or not? Yes, it's a token. Is it a keyword or identifier token? Float. Is float is a keyword or keyword token or identifier token? Yes, sir, identifier token. Because keyword token means all are small case letters. But here it is mentioned all are capital letters. So it may be a it may be an error in the program construct. But here, as per lexical analysis, it is considered as an identifier token. That's why this is one token. And else, I is also one of the token. So second token equal to operator token. So this is the total token, not a different token, sir. Dot is a special symbol. 1 is the constant. 25 is the number, not like that, sir. So we already discussed the digits are represented. So digit followed by any number of digits, followed by dot, and then followed by digit, and followed by any number of digits. These are used to recognize the float point values. So when the digit or sum of the digits came, the compiler looks for, is there any dot? Is there any dot? Because there may be a chance to be the float point value. So for that purpose, it is try to looks for the dotted value. So here it is a dotted value is there. That's why it is considered as constant or float point constant. This is fourth one. So totally there are 4 tokens, sir. Totally there are 4 tokens are there, sir. So on next one, do 5I equals to 1 comma 25. How many number of tokens are there, sir? How many number of tokens are there, sir? Do, it is the one token. 5 is the constant, and 1 is another constant, because there is a space between 5 and 1. There is a space between 5 and 1. So this is a separate constant, and this is the separate constant token. And operator 1, special symbol, comma, and 25. Sir, this is not in the specified format, sir. That is not the responsibility of the lexical analyzer. The role of the lexical analyzer is it needs to return tokens, or else if it is not a correct construct of the token, that means if it is not a keyword or a constant or special symbol or operator or any identifier, it returns lexical errors. So here it is 7 number of tokens, sir. Here it is 7 number of tokens. Okay, sir. I already explained every point how to recognize the token. So the simple point is it a token or not? So like that you have to think. How can we find the tokens? Suppose if it is a keyword. Suppose if it is a keyword, that is a token. Suppose if it is a identifier, that is also a token. Suppose if it is an operator, that is a token. Suppose if it is a constant, that is the token. Suppose if it is a special symbol, that is also a token. How can I recognize the tokens, keyword as a token, sir? So I already informed you. So keyword and identifiers are recognized by using one finite automata or one deterministic finite automata. So first it tries to read the character by character. When it is recognized as a logical entity, that is a single string, that is checks for the keyword table. Suppose if it exists in the keyword table, that returns as a keyword token, otherwise that is a identifier token. So we know about the operators. Suppose plus or minus or anything. So those are considered as operators. Otherwise constants, numbers, or floating point values, or string constant. The string constants are placed in between double quotations. The string constants are placed between double quotations. Suppose if any character constant came, so it is in the single quotations, that is also considered as a constant. That is also considered as constant token. So single quotation is not a separate token, sir, and the single quotations and C totally a single token. Coming to the special characters, the special characters are semicolon, open parenthesis, closed parenthesis, curly braces, open, closed, and colon, and all these are considered as special characters. Here you need to remember, suppose if it is a comment section, suppose if it is a comments, so those are not considered as a tokens. Those are not considered as tokens. So suppose it is started with slash star, but that is not end with star slash. Sir, that is the lexical error. That is the lexical error, because when it starts with slash star, compulsory it must ends with star slash. That's why it returns lexical error. Sir, it does not started with slash star, but it ends with star slash. Now it is considered as star as a multiplication operator, and this is division operator. So finally it returns the two tokens, two operator tokens. So these are the things you have to keep in mind, sir, to recognize the tokens. We are getting the question from the tokens, sir, from the lexical analysis or role of the lexical analyzer, or else the errors what we get at the token at the different phases, or else what are the inputs given to the one phase to another phase. From these areas you will get the question in the lexical analyzer, sir, in the lexical analyzer. So if you are having any doubts from the lexical analysis, you please ask, I will explain you, sir. Otherwise, I am going to move parsing. If you don't have any doubts from lexical analysis, I can move to the parsing. Okay, thank you. So coming to the parsing, before going to parsing, once I want to write one more time the pages of the compiler. So lexical analysis, syntax analysis, semantic analyzer or semantic analysis, intermediate, code generator, and code optimization, and finally code generation. So for this we are having symbol table and error handler. Those are connected to the each page. And here we have discussed lexical analyzer take the source program as input and produces tokens. The tokens are input to the syntax analyzer, and syntax analyzer produces parse tree. Syntax analyzer produces parse tree. So here now the question is, what is the role of semantic analyzer or parser? Another name for semantic analyzer is parser, sir. So today our class is what is the role of semantic analyzer or parser. Semantic analyzer takes the input from the lexical analysis as tokens and produces the parse tree. It takes the input as a token and produce the parse tree. For this purpose, it uses context-free grammar and push-down automata. Simply and clearly, we can say that deterministic push-down automata. There are two types of push-down automata: deterministic push-down automata and a non-deterministic push-down automata. So in that, in syntax analyzer, for producing or generating parse tree, we use the context-free grammar and deterministic push-down automata as tools. With those, we can construct or we can generate the parse tree. If that is not a parse tree, in other case, the syntax analyzer returns syntax error as an output. So finally, the syntax analyzer takes the input as a token and produces the parse tree in a valid case. Suppose in invalid case, it returns the syntax error. So this is the thing we need to discuss. So suppose if we see from lexical analysis, the lexical analyzer returning tokens or generating tokens and passing those tokens to syntax analyzer. So the syntax analyzer taking the input as tokens and producing the parse tree. For that purpose, it is using CFG and PDA, push down automata. Suppose if does not produce the parse tree, in another case it produces syntax error. So we will try to know the meaning of each word, sir. So we already know about the tokens. We already know about the lexical analysis. We already know about the role of the lexical analysis and what is lexical analysis, what is another name for lexical analysis, what it is taking as input and what it is producing as output. We clearly explained it in the previous class. And we have already know about the tokens also. What are the different types of tokens are there? When we call that is a token, or when we call that is not a token, like that also we have discussed it. Now we need to discuss what is context-free grammar. what is push down automata, and what is syntax analyzer. What is syntax analyzer, and what is parse tree. What is parse tree, and what are the syntax errors, and what are the syntax errors. When we call, the error is the syntax error. When we call, the error is the syntax error. So coming to the syntax errors, so we can see like this. Int a, int a. So this is the syntax error, because syntax means the structure of program statement. The structure of program statement, or the structure of the instruction in the program. Suppose if you see this instruction or this statement, this is the declaration. This is the declaration statement. The declaration statement syntax is data type followed by the variable name 1, followed by variable name 2, so on, separated by the commas, and ends with variable name n, and it must ends with semicolon. But here it is not ended with semicolon. It is not ended with the semicolon. This is not satisfying the structure. This is not satisfying the structure. So that's why we can say that this is the syntax error. Coming to this one, there is no lexical error. There is no lexical error, because this is the token, this is another token. This is the keyword token, and this is the identifier token. That's why here there is no lexical error, but there is a syntax error. But there is a syntax error. Why there is a syntax error? This is not satisfying the structure what is mentioned. This is not satisfying the structure what is mentioned. So that's why we can call this one as a syntax error. Syntax error. For example, int c equals to hello. Is there any syntax error in this? Is there any syntax error in this? Is there any syntax error in this? The declaration and the initialization of the statement, or the initialization of the value to the variable. So suppose if you see here, this is the data type. So okay, it is considered, and followed by the variable name. So it is also considerable. So, and by using assignment operator, we are initializing the value to the variable. So there is no syntax error, because this is also ends with the semicolon also. But there is a semantic error. But there is a semantic error. Sir, how can you say that there is a semantic error, sir? Yes, there is a semantic error, because here we are trying placing or storing the string in integer variable. Integer variable can store or can hold the integer value. But here we are trying to place or store the string constant. So here the meaning is not fulfilled. Here the meaning is not fulfilled. That's why this is the semantic error. So the semantic and syntax are very near, sir. Syntax means we need to check the structure. Syntax means we need to check the structure, and coming to the semantic, we need to check meaning. Sorry, here we need to check the meaning. Suppose the structure is good, or the structure is well formed, or that is satisfied the meaningful structure, having the meaningful structure, but there is no meaning like this. So then there is no syntax error, but there is a semantic error. Hope you understand the topic point, sir. So when we say the lexical error, when we say the syntax error, when we call, that is a semantic error. When suppose every token is satisfied. Every token is satisfied. There is no lexical errors. There is no lexical errors. Suppose if it is not satisfying the structure, what is mentioned, that structure is not satisfied, then there is a syntax error. Like this, because it is not end with the semicolon. And coming to the semantic error, so if it is having structure, even that is not satisfying the meaningful thing, so then we can call that one as a semantic error. That is called as semantic error. Hope you understand about syntax errors. So we know the syntax for any programming language. For example, there is a if condition. So the syntax is if condition, and it has to the block of statements. Suppose if you started if and you don't give the open parenthesis in C language or C++, Java, so that is the syntax error, because every condition should be in the parenthesis. Coming to the Python, that is not required. So based on the syntax or based on the structure given to the program construct or to the program statement, that has to be satisfied. So that is the responsibility of the syntax analyzer. Those who not satisfy the structure, that returns syntax errors. So here we have clear knowledge on lexical analysis and tokens and syntax errors. Here we need to discuss about what is context-free grammar, what is push-down automata, what is parse tree. So, yes, sir. Coming to the context-free grammar. So here there is a meaning in the name itself. Context free. So here, suppose int a equals to some star, like here I am trying to place character in integer. So it is not the role of like syntax analyzer. It is not correct, like, because it don't see the context. What is the variable here and what we are storing? All these are not recognized and not considerable by context-free grammar. Suppose if you take another one, context sensitive grammar is there. So here the name itself, there is a sensitive. So it senses the meaning is satisfied or not. That's why the context sensitive grammar is used at semantic analysis, and context free grammar is used at syntax analysis. Okay, good. So context free meaning, so you have some clear idea about context free, because here the context is not considerable. It is an integer value, it is a character value. Here the context is free, so we are not considering about the context. What is an integer value, what is a character value, like. But what about grammar? Grammar is a collection of rules. Grammar is collection of rules. Grammar is collection of rules to identify the strings, or to recognize the strings. To recognize or to identify the strings, we need some rules. The rules are called as grammar. The rules are called as grammar. So we are having 4 different type of grammars are there, sir. One is regular grammar, context-free grammar, context-sensitive grammar, and recursive enumerable grammar. But for this context or for syntax analyzer, we need only the context-free grammar. So grammar is nothing but collection of rules. Grammar is nothing but collection of rules to identify or recognize the strings, to identify or recognize or specify the rules for identifying the strings. So coming to the grammar, the format of grammar is like this. So alpha derives beta. It is also right like this. So alpha equals to beta. Alpha equals to beta. This is also the meaning for alpha derives beta. This is also the meaning for alpha derives beta, sir. So coming to alpha derives beta, alpha and beta are the Greek symbols. Alpha and beta are the Greek symbols which are used to hold the terminals and non-terminals, which are used to hold the terminals and non-terminals. So this is the definition and the format of the grammar. The grammar is nothing but collection of rules. The grammar is nothing but collection of rules. The grammar is in the format of alpha derives beta. Alpha is the left hand side and beta is the right hand side. So where alpha and beta are the Greek symbols which are used to hold the terminals and non-terminals. Coming to the context-free grammar, it is also in the format of alpha derives beta. It is also in the format of alpha derives beta, where alpha belongs to single non-terminal, and coming to the beta belongs to combination of terminals and non-terminals. Any combination of terminals and non-terminals. That means in the left hand side of the grammar, you should have single non-terminal. The non-terminals are represented by using capital letters, and the terminals are represented by using small case letters, and operators are also considered as terminals, and operators is also considered as terminals. So where the grammar is in the format of alpha derives beta, where alpha is belongs to single non-terminal, that means alpha non-terminals are represented by using capital letters. So that's why we can say that left hand side of the context-free grammar, we are having only single non-terminal. And coming to the right hand side of the rule or production, we can also call the rules or productions. So we can in the right hand side of the rule, we may have combination of terminals and non-terminals. So that is the context-free grammar. This is the context-free grammar. Coming to this context-free grammar, we are having 4 tuples to represent it. NTPS. The 4 tuples are NTPS. So for any grammar, there are 4 tuples to represent the grammar. So those are NTPS. N for non-terminals. So we can also write it as VTPS. So variable or non-terminal, both are same, sir. Variable or non-terminal, both are same. So second one is T for terminals, S for start symbol, and P for productions. So coming to this example, here the start symbol is S, and the terminals are non-terminals are. What are the capital letters are there, sir? S, A, B. So all the capital letters are comes under non-terminals. So A comma B comma S are non-terminals. Coming to the terminals, A, B, and epsilon. A, B, and epsilon. So these are the terminals. Coming to the productions, here we are having productions, one production, second production, A derives AA, third production, A derives epsilon, fourth production, B derives BB, 1, 2, 3, 4, 5, 6, 7. So S derives A or B means S derives A and S derives B. Here we are having two productions. So this is the explanation regarding context-free grammar or any grammar, sir. Context-free grammar means a grammar which is in the format of alpha derives beta, where alpha is the single non-terminal and beta is the combination of terminals and non-terminals, or any combination of terminals and non-terminals. Here we have written, so star or asterisk. That means epsilon is also considerable. Epsilon is also considerable. And coming to the grammar, any grammar, it is represented with four tuples. That is NTPS or VTPS. N or V. N for non-terminal, V for variable. Both are same. T for terminals, P for productions, S for star symbol, sir. S for star symbol. Can anyone please help me? How many number of productions are there, and what is the star symbol, and what are the terminals and what are the non-terminals here? S derives ES or S. S derives capital AA, small a. So can anyone please help me? What is the start symbol here? What is the start symbol here? Is S or E? Okay, sir. So here E is the start symbol, not S, sir. Even there is a production with S, so we need to consider the starting production left hand side non-terminal is the start symbol. So don't forget it, sir. Otherwise, you may get the chance to give the wrong answer. So that's why you need to remember the issue or the thing, that is the first production. The first production. What is the first production here? E derives ES. In that, the leftmost non-terminal or the left-hand side non-terminal. What is the left-hand side non-terminal? E. So here E is the start symbol, and the non-terminals are E comma S comma A. E comma S comma A. And the next one is terminals. Coming to the terminals, only A is the terminal. And coming to the productions, the productions are E derives ES, E derives S, S derives AA, S derives A. So these are the productions. These are the productions. Here my point is how to check the start symbol. Always the start symbol is the first productions left hand side non-terminal. So what is the non-terminal presented in the arrow mark is the start symbol, and that should be the first production, and that should be the first production. So that is the non-terminal, sir. That is the that is the start symbol, sir. That is the start symbol. So you may get some boring like, because we are not doing some problems. We are taking only theoretical class. So, but very, very important, sir. Theory is very, very important. Why? Because, sir, so we need a clarity on the definitions and meaning of the things. Without having the proper idea about the meaning and the definitions, there may be a chance to do some errors. So for that purpose, we need to having the clarity on the definitions and the meaning of the terminology. The terminology is more important for compiler design. The terminology is more important for compiler design. Suppose if you take a data structures or anything, so in that, suppose if you want to construct a binary search tree, no need about the terminology. So most of the that is not a mandatory. That is not a mandatory. You need to know the one principle, that is the all the nodes which are present in the left side should be the less than the root node, and all the nodes which are present in the right side, that should be the greater than the root node. So that is nothing but simply we can say that that is a binary search tree. Like, so in that you no need to having the what is the leaf node, what is the parent node. So only the root node and the left subtree, right subtree is enough. We are having so many definitions in a trees, siblings and ancestor. Those all things are not required in that area. But here, the every definition is interlinked. So that's why you need to know the terminology is more important, sir, here. So okay, good. So just we will see some problems, sir. So what is the height of parse tree? What is the height of parse tree constructed for the input? What is the height of parse tree constructed for the input x, 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 y, z, z for grammar, for given grammar S derives x, x, w slash y, and w derives s, z. So this is the given grammar, sir. With this grammar, we need to accept this string. For accepting this string with the given grammar, so what is the height of the parse tree? What is the height of the parse tree? So here we need to know what is parse tree. What is parse tree? Sir, for example, yeah, you please come back, sir. Yeah, here there is a parse tree. So what is a parse tree? The output of lexical analyzer. The output of lexical analyzer. How can we give the? How can we derive output with the help of context-free grammar? So listen carefully, sir. Here, what I am telling is, what is parse tree? Parse tree is the output of the syntax analyzer. Parse tree is the output of syntax analyzer. How we are deriving parse tree? With the help of context-free grammar. With the help of context-free grammar. So with the help of context-free grammar, we are producing the parse tree. That's why here the given question as what is the height of parse tree? Here the context-free grammar is given and a string is given. We need to construct the parse tree for this. We need to construct the parse tree for this. For producing the parse tree, we are having two methods. That is LMD and RMD. Sir, what is LMD? What is RMD? LMD means leftmost derivation. Leftmost derivation. RMD means rightmost derivation. Sir, when we call the derivation is leftmost, when we call the derivation is rightmost. Yes, sir, you please see. Here, suppose if you take S derives x, x, w, x, x, w slash y. Here we need to accept the string x, 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 y, z, z. So for that purpose, suppose if you start at root, there are two possibilities. X, x, w is there, y is there. So what we have to take? xxw, because our string is matching with xxw. That's why I am considering xxw. xxw. It is the terminal and it is the terminal. Coming to the here, the w is deriving or the w is generating s z. So that's why I am writing s small z. S small z. I already told you. So here alpha derives beta is equivalent to alpha equals to beta. That means you can place alpha is equals to beta. In place of alpha, you can write beta. Here this is alpha and this is beta. We are replacing alpha by using beta. So that is the thing we are doing. So coming to the s, again s is x w or y. So after two x's, again I need not a y, I need again x. So that's why I'm taking x w. So coming to here, x is completed, x is completed, x is completed, x is completed. Now I need y z. Now I need y z. So for that purpose, I am producing w as s z. So s is y, sir. S is y. So finally, what is the height? So 1, 2, 3, 4, and 5. So the height of the parse tree is 5, sir. The height of the parse tree is 5, sir. So one more time I will write it here, sir. So maybe it's some confusion is there. So x w, and w is produced as s z, and s is produced as x w, and w is written as x, and it is written as y. So from here we can say the height is 1, 2, 3, 4, 5, sir. So the height of the tree is 5, sir. The height of the tree is 5, sir. Sir, how can we say the height? So from root to leaves, how many number of edges are there? In the longest path. In the longest path. Suppose if you see here, this is the leaf node. So only one edge is there. So coming to the longest path. So this one and this one and this one, coming to this one, sorry sir, this one, and coming to this one, and again this one. So in this path there are 5 edges are there, so that the height of parse tree is the height of parse tree for the given grammar and given string is 5, sir. So take one more example, sir. Take one more example. S derives A S or A B, and A derives small a, capital B derives B capital C slash small d B, and capital C derives small c. So this is the given grammar, sir. For this given grammar, we need to construct, we need to identify, or we need to accept the string A, D, B, C. D, B, C. So this is the string, sir. This is the string, sir. For this string, we need to construct the parse tree. For this string, we need to construct the parse tree. We need to write the height of the parse tree. We need to write the height of the parse tree. So again, I am starting at root. So the root is yes. So from the root, we can derive AS or AB. AS or AB. So suppose if I take AS, so there is a chance to take one more AS. So I need 3 AS. Suppose if I take AB, so here A means A, B means there is no chance to go back. for reading AS. That's why I'm taking A, sorry, A, yes, A, yes, yes, sir. Here, you please see, sir. So here I can reduce capital A as well as I can reduce capital S. Suppose if I reduce every time the leftmost non-terminal, if I reduce, that is called as LMD. That is called as LMD. So here capital A is reduced as small a, and there is no leftmost non-terminal here. So I am moving to the S. So S means again A, yes. Here the leftmost non-terminal is capital A. So that's why I am placing A, because I need to read A. So again, so I am placing A, B here. Sir, why you are taking B, sir? Why don't you take for AS, sir? AS means S is again AB. Again AB means here and A. Again AB means one more A is there, sir. So that's why. So I need only 3S. That's why I am moving to B, sir. So coming to B, BC is there and DB is there. So after 3 years, I need D. After 3 years, I need D. So that's why I am taking here small d, capital B. Small d, capital B. Coming to the capital B, so I can write BC or DB. So after D, I need a small b. That's why I am moving to small BC. Small BC. So coming to here, the small c. So finally A, D, B, C. So A, D, B, C, sir. So that is accepted. So what is the height? 1, 2, 3, 4, 5, 6. So what is the height here, sir? That is 6, sir. That is 6, sir. So here you need to get the knowledge what is LMD, sir, and another one is what is RMD, sir. So the knowledge of LMD is, or the definition of LMD is, suppose if you want to reduce the non-terminal with a terminal, that is done always the leftmost non-terminal. The leftmost non-terminal. Suppose if you do the leftmost non-terminal, or if you place leftmost non-terminal, we can call that one as LMD. Suppose if you always replace rightmost non-terminal, you can call that one as rightmost derivation. So construction of LMD, RMD in a tree format is called as leftmost derivation tree and rightmost derivation tree. Writing the tree for the LMD or writing the tree for RMD is called as derivation tree. So hope you got the terminology. What is derivation? What is derivation tree? So derivation means accepting or constructing the string, for given grammar or with given grammar. So for constructing a string with a given grammar or for given grammar is called as derivation. For example, S derives AB, A derives small a or epsilon, and B derives small b or epsilon. Here I need a string AB. For constructing AB, I am taking S, and from S2 I am taking AB, and A is replaced with small a, and next B is replaced with small b. Here I have constructed the string. I have constructed the string with the help of given grammar. With the help of given grammar. So this is nothing but derivation. This is nothing but derivation. Sir, meanings are more important. Meanings are more important. You just see, and if you don't understand, you please ask, sir. I will again explain you. So without having the differentiation of the meanings, so it is difficult to understand the problem, and if you it is difficult to give the answer to the problem. That's why I am telling, sir. So derivation means constructing the string for the given grammar, or with the given grammar we need to construct some string. So the process is called as constructing process is called as derivation, not a derivation tree, sir. Called as derivation, sir. That is called as derivation. So coming to the derivation tree, derivation tree is nothing but producing this derivation in tree format, in tree representation. Tree representation is called as derivation tree. So representing the derivation in tree format, or derivation is represented in the tree format, is called as derivation tree. Another name for derivation tree is called as parse tree. Another name for derivation tree is called as parse tree. Another name for parse tree is called as syntax tree. Another name for parse tree is called as syntax tree. So finally, so we need to construct parse tree from syntax analyzer. So for that purpose, we are using context-free grammars. For that purpose, we are using context-free grammars. So here we saw how to construct the derivation, how to construct the tree for the given grammar from the, how to construct the string from the given grammar. So this is the thing of the context-free grammar, sir. Suppose if there is a grammar, we need to say the language accepted by the grammar. S derives small a s, small b s, small b capital S, small a capital S, and epsilon. So this is the given grammar, sir. So what is the language produced by this grammar? What is the language produced by this grammar? What is the language produced by this grammar? Okay. Here S is directly deriving epsilon. So one is epsilon. The language is one is epsilon. Suppose if you place S as epsilon, if you place S as epsilon, S as epsilon, the string is AB. The string is AB. Here also, suppose if you produce epsilon epsilon, the string is BA. The string is BA. And next, suppose if you take A, S, B, S, and here if you place epsilon, and here if you place B, S, A, S, and this S1, this S, and this S is epsilon epsilon. The answer is A, B, A, B. That's why A, B also accepted. Or else A, S, B, S. Suppose here if you place again A, B, A, S, B, S. So that is A, B, B also accepted. A, B, B also accepted. Suppose in this case B, S, A, S. Suppose if you take B, suppose if you take B, S, A, yes. Suppose this one is epsilon, this one is epsilon. B, B, A, A. B, B, A, A. Or else B, A, B, A. So these are the total string. These are the kind of strings we may generate with the given grammar set. Suppose if we see this grammar, we can say that here 0 number of S and 0 number of B's. Here 1A, 1B. Here 1A and 1B. Here 1, 2. 2A's, 2B's. Here also 2A's, 2B's. Here also 2A's and here also 2A's and 2B's. And here also BBAA. So here we can say that the language accepted is equal number of A's and equal number of B's. Equal number of A's and equal number of B's. Suppose 2 A's are there, 2 B's are there. So the order is whatever it may be. Suppose starting A's and after that B's, or some A, B's followed by A's, like that. Total number of A's and total number of B's are equal. So this is the grammar for accepting the language. The number of A's and the number of B's are equal. The number of A's and the number of B's are equal. If anyone are having doubt on this, you please ask, sir. Once again, I will explain. So the grammar is given, and from the given grammar, what is the language accepted? Like that, he is asking. Okay, I will ask the question. You please answer, sir. Why not even number of A's and even number of B's? Why the given grammar is not even number of A's and even number of B's? Why it is not even number of A's and even number of? Because here 0, 0, here 0, 0, and here 2, 2. But coming to here, only 1A. Is there even number of A's? Even number of A is there, sir? Even number of A is there? No, sir. Or else you can ask, we can take one more question, sir. What is the even length strings? What is the, why it is not even length string? Because here it is 0, here it is 2, here it is 4. So the length of the string is even. Why not we call it as even length strings over A comma B like? Even length strings over A comma B like. In this, we may have the string 4 A's or 2 A's or 2 B's or 4 B's also. But all these are not produced by this grammar. That's why we are not calling that one as a even length strings over A comma B. And like that we are not calling. So we are calling, or we are giving the answer as equal number of A's and equal number of B's. Equal number of A's and equal number of B's. The order may be anything. First, we can start with A's or we can start with B's, sir. We can start with A's and we can start with B's. So this is the way to find the language for the given grammar. This is the way for finding the language for the given grammar. Suppose if you take one more example, sir. Suppose A or B and A or B. So what is the language produced by the given grammar? What is the language produced by the given grammar? Take a 2 minutes, sir. Try it. What is the language produced by the given grammar?
Triple A, triple B, ABA, BAB.
Yes, sir. Yes, sir. One second, you please tell me. Triple A,
Triple B,
triple B,
ABA,
A,
BA,
BA. Oh, okay.
BAB.
BAB,
Antes.
and so on like that. Okay. So we can add some more, sir. So what is that? Directly S is deriving A, small a. That's why A is also the string. And directly S is deriving B. That's why B also the string. So is there epsilon? No, sir. So that's why A, B, triple A, triple B, A, B, A, B, A, B. And one more thing, if you take, suppose A, S, A and B, S, B. Suppose A means A. Here we are getting A, B, A, B, A. So we may get the answer as A, B, A, B, A. Suppose if you take S, A, S, A and A, S, A and A. So these are 5 A's. Here if you see, 1 length strings are there, 3 length strings are there, then 5 length strings are there. Suppose if you see, all the strings lengths are odd. All the strings lengths are odd. The first point is the length of the strings are odd. And one more thing, if you recognize, A, the reverse of the A also A. The reverse of the B also B. The reverse of A also A. The reverse of the B is also B, A, again this B. Suppose if you reverse it, here A, B, A, B, A. So these two are equal. So like that, we can say that these are palindromes. These are palindromes. It is recognizing as palindromes. It is not recognizing A, B. We can't recognize it. So or else B, A. It is also not recognized by this one. Or else A, or A, B. Like that, we are not able to recognize. So that's why all these strings accepted by the given grammar are only the odd length strings and all are palindromes. That's why we can say that odd length palindromes. The grammar is for accepting the language of odd length palindromes. Okay. Once again, I will go back, sir. So here I am explaining you context-free grammars. So the context-free grammar responsibility is for recognizing or for specifying the rules. What are the rules specified by the context-free grammar? To accept the strings. It gives some rules or it specifies some rules. With these rules, we can accept the strings. Collection of strings is nothing but language. With these rules, we accept the strings. For that purpose, we need to derive a string. The deriving of string is called as derivation. So the derivation is represented using tree. We are calling that one as derivation tree or parse tree. Suppose if you know the grammar, you can find the string acceptancy. You can check the string acceptancy. Not a finding, sir. Sorry. It is a checking of the string is accepted or not. Or what is the language produced by the language, and what is the height of the tree. With grammar, you can check the what is the height of the parse tree. You can check the given string is acceptable, or the given string is accepted or not, or else it can check what are the language accepted by. What is the language accepted by the given grammar? What is the language accepted by the given grammar, sir? So next one, take one more grammar. S derives T comma, S derives T space D semicolon. T derives int R float, D derives I R I comma D, I derives small a, small b, small c, so on, small y, small z. So this is the given grammar, sir. This is the given grammar. So this is the previously asked question, sir. What is the statement accepted by the following grammar? What is the statement accepted by the following grammar? Sir, before going to that, what are the different kind of statements? What are the different kind of statements are there? What are the different kind of statements are there? So declaration statement is there. In programming languages, what are the different type of statements are there? I am writing, sir. One is declaration statement. Second one is conditional statement. Next one is input or output statement. Next one is procedure or function. And next one is expression. These are the different kind of statements in a program. These are the different kind of statements present in programming. So now the question is, this is the given grammar. With this grammar, what type of statement is accepted? So that is the need. We need to check. So here, suppose if you take S is deriving T followed by D followed by semicolon. So you can replace T with int or float. Suppose if I replace it with int, so we can take anyone, sir. Suppose I am trying to take int. So I am replacing T with int. So T is the non-terminal and int is the sentential form. Int is the sentential or handle. So I will explain what is sentential form, what is handle. So how to reduce the handle also I will explain, sir. Don't worry. So you just see how to identify the statement. Here you just see how to identify the statement by drawing the parse tree. Here there are two chances. I can replace T, I can replace D. Here I am trying to construct LMD. That's why I replaced T with int. Next, so this is completed. Because this is the terminal. Next, coming to the D, I can replace with D with I or I comma D. Suppose if I take I comma D, here I is replaced with some A and D is replaced with some I, and again I is replaced with B. So it looks like int A comma B comma semicolon. So what is this? Is it an expression, or is it a declaration, or is it a condition, or is it an input or output, or is it a function or procedure? What statement it is, sir? This is the declaration statement, because here we are declaring two variables A and B. Those are integer type. Those are integer type. Sir, how can we differentiate it? How can we differentiate it? How can we differentiate it? Coming to input output, there are printf or scanf. With this you can separate. Coming to the procedure, all procedure names end with open parenthesis and closed parenthesis. That's why we can identify, is it a procedure statement or input or output statement. Coming to the conditional statements, there are some conditional or control statements, or conditional statements are there, and unconditional statements are also there. So coming to the conditional, if, else, while, for, switch, all these are there. With identifying these keywords, we can say that is the conditional statement. That is the conditional statement. Coming to the expression, so we need to write it, sir. So coming to the expression, suppose S derives E, S derives SE, suppose, and R, E, here E derives E star E, or else E plus E, or else E minus E, or else E divided by E, like this. So here, suppose if you see here, so you need to have the state expression statement as in this format. Expression statement as in this format. Sorry, sir. Small change. I is equals to E. Sorry, sir. S derives I is equals to E. Here I is an identifier. And E is expression. That expression may be multiplication, or that expression may be addition, or that expression may be subtraction, or that expression may be division. Suppose if we are having expression like this, n is equals to n into n plus n, like this. So we can recognize this string or this expression like this. S derives I equals to E. Coming to the E here, so there are E plus E, and here we can write E derives E star E. Suppose if it is n, it is also n, and it is also n. So n equals to n into n plus n. So this is accepted by the given expression, or for the given string. So finally what I am going to say is, so this is also the frequently asked gate question, sir. This is the frequently asked gate question. So what it is? What type of statement accepted by the given grammar? What type of statement accepted by the given grammar? With this given grammar, we can accept the declaration, because expression is not acceptable, because expression format is like this, look like this. S derives I equals to E. So this is not in that format. That's why this is declaration, and it is not conditional, because if, else, while, or for, or switch, anything is not there, break or continue or anything is not there, that's why that is not a conditional statement. Coming to the or else unconditional statement. Coming to the input or output, so for input or output, we are having printf and scanf. So those are also not present in this grammar. That's why that is not a input output statement. Coming to the procedure, so to accept the procedure, to identify the procedure, the name must end with the open parenthesis and closed parenthesis. Here in the given grammar, there is no open parenthesis and closed parenthesis. That's why that is not procedure or functional statement. So finally, that is the declaration statement because it is satisfying the declaration. So here I will give one more thing, sir. Please don't depend upon the answers. In GATE examination, the trapping is very, very important. Suppose if you depend upon the answers, you will get the negative marks. What I am trying to say is, suppose if it is the correct answer, you have to knowledge why these are not the correct answers. Then only you have to give the options. Without knowing, without considering all these, you don't just give this one as a correct answer. So sometimes it may be lead to the negative marking. That's why you need to check before you give the answer. And the thing you need to consider is the remaining are not correct. So why those are not correct? Like that only you need to think. So then only you will escape from the negative marking. Otherwise, you may get the negative marks and your score will be decreases. So that's why. So you need to clear idea what is the correct answer and the remaining options are not correct. Why? Because. So that is the thing, sir. So next one is coming to the context-free grammars. There is a problem in the context-free grammar. What is that problem? Suppose if you take a grammar, S derives A. To accept the string, A. S is deriving SS. First S is replaced with A and followed by again SS, and second S is represented by A. So A is accepted. So okay, good. And again I am trying to write one more trick for this. I am replacing this S with A and this S with SS. Here it is A. You need to check here, these two trees or parse trees are equal or not, are the same or not. Sir, how can we say equal or not or same or not? So you just see the structure. This structure is different and this structure is different. That means for the same grammar and for one input, we are writing more than one tree or one parse tree. Writing more than one parse tree for any string with a context-free grammar. That grammar is said to be ambiguous grammar. If any grammar is producing more than one tree or more than one derivation for at least you just please concentrate on this definition, sir. For at least one string, if we write more than one tree, then that grammar is ambiguous grammar. ambiguous grammar, because any grammar can produce a language. In language, we may have more number of strings. In that strings, at least for one string, it is producing more than one parse tree. Then the grammar is said to be ambiguous grammar. Suppose if the context-free grammar is ambiguous, we cannot construct parse tree. So for that purpose, we need to check before going to construct a parse tree. Is it a ambiguous construction of parse tree? Is not possible here. When suppose if it is ambiguous grammar, suppose if it is a unambiguous grammar, then we can construct parse tree. Sir, why it is unable to construct parse tree? Parse tree means the syntax analyzer is there with the given tokens or with the given grammar, tokens and grammar. It has to accept one tree. Suppose if the grammar is producing more number of trees, tree 1, tree 2, tree 3, tree 4, like that means parse trees. So which parse tree has to be recognized by the syntax analyzer? That is the confusion. That's why we need to check before going to construct a parse tree. The given grammar or given context-free grammar is ambiguous or unambiguous. Suppose if it is unambiguous, we can move forward. Suppose if it is ambiguous, we cannot move forward. So the thing is, we need to check the given grammar is ambiguous or not. Like, so when we say the grammar is ambiguous grammar, suppose if any grammar is producing more than one parse tree for any one of the string, or at least for one string, then we can call that grammar is ambiguous grammar. So before going to construct a parse tree, we need to check the grammar is ambiguous or not. Yes, sir. Previously asked gate question. Which of the following grammar is unambiguous? Which of the following grammar is unambiguous? Option A or option 1, S derives, SS small a. Option B, S derives, A derives, small a, capital A, and small a. Option C, S derives, A, B, A derives epsilon, B derives epsilon. Option D, none of the above. Yes, sir. You try to write some string and take some string for any string and try to write a parse tree. If it is producing more than one parse tree, that is a ambiguous grammar. Here the question is unambiguous grammar. Check the unambiguous grammar. Like that he is asking. Yes, sir. If you want to try, you please try. Please take a 2 minutes. Try it, sir. Which grammars are ambiguous grammars and which grammar is unambiguous grammar? Yes, sir. Any answer? Any answer? Sorry, A, B, C, D, sir. 1, 2, C, D, not like that. 1, 2, 3, 4, 5, or any order. Okay. Any answer, sir? Okay. Okay. I will explain. Suppose first one, if you take first one, yes derives, yes derives, yes. For first S, it is A, and next again for second S, I am taking S again, and for first S, I am putting A, and for second, I am putting A, sir. And coming to another order, I am trying. It is an ambiguous grammar. I am trying. It is an ambiguous grammar. That's why I am intentionally drawing this one. Yes. For yes, I am taking S and S, A, and this is replaced with A. So both are recognizing or accepting the same string AAA, but the structure is different. So that's why for single string A, it is producing more than one parse tree. So more than one parse tree on there, and suppose is there more than one parse tree, that is called as ambiguous grammar. So this is ambiguous grammar. So first I am taking AAA as a string, and I am trying to draw the parse tree. For LMD, I am getting this one, and for RMD, I am getting this one. Sir, which we need to consider? Sir, you can write any two LMDs or two RMDs. RMD. When you write or when you construct two LMDs or when you construct two RMDs or one LMD and one RMD, in any one of the case, if you get the two different trees, the grammar is ambiguous grammar. Okay, next. Coming to the second one, sir. So in the second one, suppose you just take here also 3s, sir. Here also I want to take 3s. So S derives A. For first A, I am writing A, and then A. So after that, again S derives A. For first A, I am writing small a, and second A, I am writing A. So this is A. So here also, this structure is different from this structure for the same string. That's why this is also ambiguous grammar. Sir. Coming to the third one. So right, here I am taking AB, AB. I am taking the string AB, AB. I am trying to write the string AB, AB. So for that purpose, S derives A, small a, capital A, B. And if I try to replace A with epsilon and A with epsilon, sorry sir, AB is not possible because we can't produce capital A to another AB. So AB, only AB sir. So AB is produced. And again, suppose if anything you replace, first you replace this one, and after that after you replace this one, AB only. Suppose coming to this one, B, 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 A. So S derives. Suppose if you replace first this one, after this one, or first replace this one or this one. So the tree is same for LMD and RMD. Other than this, no other way to represent this one, because here the language is AB and BA. The language is AB and BA. That's why this is unambiguous grammar. So here we got the answer. That's why none of the above is wrong. So here none of the above is wrong, sir. So finally the unambiguous grammar is C, sir. So A and B both are producing more than one tree for a string. So that's why those two are ambiguous grammars. Those two are ambiguous grammars, sir. So this is about the finding the grammar is ambiguous or not. So once you please come to starting, sir. Yes. Yeah. Okay. So here what we learning, lexical analysis. We know about the lexical analysis. We know about the tokens. Now we know about the context-free grammar also. Context-free grammar is the grammar which is in the format of alpha derives beta, where alpha is the single non-terminal and beta is the combination of non-terminals and terminals. And with this context-free grammar, we discussed how to recognize the tokens, how to recognize the string, how to recognize the language, how to recognize the height of the parse tree, how to construct a parse tree, what is LMD, what is RMD, all these things we discussed. Coming to here, parse tree. Parse tree is nothing but a derivation tree. Derivation means the process of deriving a string from the given grammar. The process of deriving a string from the given grammar is nothing but derivation. Representing the derivation in the tree format. Representing the derivation in the tree format is nothing but parse tree or derivation tree. So hope you understand what is lexical analysis, what is tokens, what is a context-free grammar, what is a parse tree, what is a parse tree. Sir, here I am having a question. What is the difference between parser and parsing? Parser and parsing. What is the parser and parsing? We know about the parse tree. Parse tree, we know about it. What is parser? What is parsing? What is parse tree? Parse tree is nothing but a derivation tree. Parse tree is nothing but derivation tree. What is derivation? Derivation is nothing but process. Derivation is nothing but process. What is that process? What is that process? Accepting the strings. Accepting the strings for the given grammar. For the given grammar. So we know about the parse tree clearly. We know about the parse tree clearly. What is parser? What is parser? What is parsing? Sir, parser is nothing but program. Parser is nothing but program. So which, with the help of parser only, we accept the strings. With the help of parser only, with the help of syntaxal analyzer only, we construct the things. So things means strings. So context free grammar is the tool. Context free grammar is the tool, and parser is an algorithm. Parser is an algorithm or program. Parser is an algorithm or program which is used to do all these process. Which is used to do all this process. So parse tree is nothing but the derivation tree. That derivation tree which is generated by the parser. The derivation tree or parse tree is generated by the parser. The generating process of parse tree with the help of parser is called as parsing. Is called as parsing. So parser means a program. Parser means a program. In the starting class itself, I told you lexical analyzer is the program, parser is the program, semantic analyzer is the program, intermediate code generator is the program. Every phase is considered as a program or subprogram in the process of compilation. What is a compilation? Compilation is nothing but, or compiler is nothing but converting the high level language into low level language. Converting the high level language into low level language. For this process, we are using many programs. For this process, we are using many programs. The group of programs is called as software. So the compiler is the software. Compiler is the software. In that, we are having lexical analyzer, parser, and all these things. So yes, sir. So once again, I repeat what I discussed in this class. So I discussed in this class what is context free grammar, what is CFG, and how to represent CFG, So some theory is more theory is there in this today's class, sir. So you just understand the terminology. So for tomorrow class, I will prepare. I will give more problems which we discussed today. So next one is what is context free grammar, how to represent context free grammars, how many number of or types of context free grammars. Types of context free grammars are ambiguous, ambiguous and unambiguous grammars. Ambiguous and unambiguous context free grammars. And coming to the next one is what is parse tree, what is derivation tree, what is parse tree and what is derivation tree. We discussed what is a derivation, what is the derivation, what is parsing, what is parsing, and what is parser, and all these things we discussed, sir. And in this area we discussed about what is grammar and types of grammar, what are the tuples in the grammar, what are the tuples in the grammar. So these are the terminology I discussed in today's class, sir. So from this class, what are the gate questions we may get? From this class, what are the type of gate questions we may get? So what is the statement accepted by the given grammar? What is the statement accepted by the given grammar? This question you may get, and that is the frequently asked question, many number of times asked question. The question is the declaration statement. So that is that looks like S derives T D semicolon, like so. This one, this is the frequently asked question, sir. So finally here I discussed how many number of statements are there. How many number of statements are there? Declaration statements are there. Declaration statements are there. Expression statements are there. Expression statements are there. And expression statements are there. And conditional statements are there. Conditional statements are there. And procedure or functional statements are there. And coming to last one, input and output. Input and output statements are there, sir. So from all these, we need to recognize what kind of statement it is. What kind of statement it is. Sir, is it a responsibility of lexical analyzer? No, sir. Lexical analyzer can recognize up to a single token. Lexical analyzer can recognize up to a single token. So it cannot recognize the total statement int a. This is not recognized. Lexical analyzer only recognizes this is one token and this is another token and this is another token. Those are separated. But this is the one statement. What type of statement it is? This is the declaration type statement. This is the declaration type statement. Sir, how can we say? So this is started with the data type followed by the variable name and ends with the semicolon. So that structure is the declaration statement structure. The structure is declaration statement structure. So that's why. So we can say that this is the declaration statement. Like this is the expression statement. Like this is the conditional statement. How can we say conditional statement? If that includes is a keyword, if, while, for, and all these. Suppose we know about the control statements of the conditional control statements and unconditional control statements are there, sir. So those keywords, switch, while, do, for, if, else, else if. So all these are the keywords. Suppose if any one of the keyword is there, so we need to check that is the expression statement. And sorry, sir, conditional statement. So the expression statement is look like this. S derives I equals to E, where assignment operator is there. So that is called as expression statement. Coming to the E, E is derived as E plus E, or E is derived as E minus E, or E is derived as E into E, like that, sir. So these are the things. So from this class, we have discussed about the context-free grammars mainly, and what are the types of the context-free grammars. How can we check the given grammar is ambiguous or unambiguous? Any grammar is producing more than one tree for at least, don't forget it, sir, for at least one string, for not required to produce for all strings for at least one string. If it produces a more than one parse tree, then we can call that is the ambiguous grammar. Suppose if it is the ambiguous grammar, we cannot construct, we cannot means syntax analyzer cannot construct parse tree. So only for the unambiguous grammars, the syntax analyzer can produce the parse trees. Otherwise it produces errors. For constructing the parse tree, we need to write the derivation. The derivation is two formats. One is LMD, another one is RMD, LMD means leftmost derivation, RMD means rightmost derivation. Coming to the LMD, every time we replace or we reduces leftmost non-terminal. If you reduce or if you replace leftmost non-terminal for producing the string, so then we can call that one as leftmost derivation. Otherwise, that is called as, sorry, not otherwise. Suppose if you always replace or reduce rightmost non-terminal, that is called as RMD. Suppose if you construct LMD as a tree representation, we can call that one as leftmost derivation tree. Suppose if you construct RMD as a tree representation, then we can call that one as rightmost derivation tree. So this is the terminology, sir, we have discussed. Here you get the questions like, one is what is the statement accepted by the given grammar? Another one is the given grammar is ambiguous or not? Is the given grammar is ambiguous or not? Like this also you will get the questions, sir. Most of the questions you will get from this topic is what is the statement accepted by the given grammar, and second one is the given grammar is ambiguous or not? Is the given grammar is ambiguous or not? So many different terminology I discussed in this class, sir. You please see it. Suppose if you want to learn more, you go back and in theory of computations, what is the leftmost derivation tree, what is the rightmost derivation tree, what is a context free grammar, what are the different type of context free grammars, how can we produce grammar to language or language to grammar, like that you can see, sir. So, and in that in formal language and automata theory, there is a concept of ambiguity also. So you can check if the given grammar is ambiguous or not, what is LMD and what is the RMD, all these things. You just revise in your previous academics what we covered, or in the previous GATE classes, like. So then you will get the good knowledge. So in the next class, I will explain about the PDA. So here we have one more concept. To move to the problems, here we are having one more concept, sir, that is PDA. Here we discussed about lexical analysis. Here we discussed about tokens. Here we discussed about syntax analyzer. Syntax analyzer is nothing but parser. So we know the parser. Parser is nothing but generating the parse tree. So the process is called as parsing. So we know about the context free grammars. We know about the parse tree. If the derivation tree or parse if the derivation is represented in the format of tree, so then we can call that one as parse tree. Here we know about syntax errors, how the syntax errors are there. So like one more concept is there, that is called as PDA. What is PDA? PDA is nothing but a mathematical model. So how it is useful for construction of parse tree, I will explain tomorrow class, sir. With this we will do some more problems also. How to construct the parse tree. So there are different ways are there. Top down approach is there, bottom up approach there. Everything I will explain in the next class. Thank you. If anyone are having any doubts from this class, you please ask, sir. Otherwise I will close the session. From these concepts or what I have discussed, if you are having any doubts, you can ask. Yes, sir. Thank you.